Welcome. We are going to solve two examples about the DC load line. Example 1. Determine the quiescent point or Q point for the common emitter circuit in figure below and draw the DC load line. The current gain of the transistor or beta equals 100 and VBE equals 0.7 volt. Solution. The Q point is determined by the values of IC and VCE. First of all, we apply Kirchhoff's voltage law to loop 1, and we get equation 1. By rearranging the equation, we get IB, which equals 186 microamperes. The collector current IC equals beta multiplied by IB, and the result is 18.6 milliamperes. Now we apply Kirchhoff's voltage law to loop 2, and we get equation 2. By rearranging the equation, we get VCE, which equals 10.7 volts. So, the Q point is located at IC equals 18.6 milliamperes and VCE equals 10.7 volts. To draw the DC load line, we have to locate the saturation point on the IC axis and the cutoff point on the VCE axis. The saturation point is located at VCC over RC. This point is derived from equation 2. By substituting 0 for VCE and rearranging the equation, we get IC equals VCC over RC. The cutoff point is located at VCC. This value is also derived from equation 2. By substituting 0 for IC and rearranging the equation, we get VCE equals VCC. Now we draw the load line, which is a straight line that connects the 2 points. To plot the Q point, we have to locate VCE, which equals 10.7 volts, and IC, which equals 18.6 milliamperes. And this is the Q point. Let's define the saturation point as 0.1 and the cutoff point as 0.2. To calculate the slope of this line, we use this mathematical formula. We can directly find the slope by substituting above, and the result is minus 2 milliamperes over volts. Example 2. Determine the Q point for the common emitter circuit in figure below and draw the DC load line. The current gain of the transistor or beta equals 150 and VBE equals 0.7 volt. Solution. First of all, we apply Kirchhoff's voltage law to loop 1 and we get equation 1. In this equation we have two unknowns, which are IB and IE. IE approximately equals IC, which equals beta multiplied by IB. So we substitute beta IB for IE in equation 1, and we get this equation. By rearranging the equation and taking out IB as a common factor, we get IB, which equals 46.5 microamperes. The collector current IC equals 6.975 milliamperes. Now we apply Kirchhoff's voltage law to loop 2 and we get equation 2. And by rearranging the equation, we get VCE, which equals 9.537 volts. The Q point is located at IC equals 6.975 milliamperes and VCE equals 9.537 volts. The saturation point is located at VCC over RC plus RE. This value is derived from equation 2. By substituting 0 for VCE and then IC for IE, we get this equation. And by rearranging the equation, we get IC equals VCC over RC plus RE. The cutoff point is located at VCC. This value is also derived from equation 2. By substituting 0 for IC and IE, we get this equation, and by rearranging the equation, we get VCE equals VCC. And this is the DC load line. Now we locate VCE and IC to plot the Q point. Thank you very much.